Okay, here we have to propose a possible mechanism for this transformation and explain the observed stereochemistry. So looking at compound A to compound B, I see the carbocation move 2 units to the left, and also I see there's no methyl group here. Okay, we are in the tertiary carbocation here, and what you're not really seeing is the hidden hydrogen or implied hydrogen that's attached to this carbon up here. So remember one of the 4 mechanisms, the main mechanism discussed in this chapter. This is what we call hydride shift. It's part of the rearrangement for the carbocation. So he's gonna move to the next carbon, and then in turn we're gonna get like positive carbocation for this specific carbon, because now we no longer have the hydrogen with the bond together. So we have a plus sign, and when you get the carbocation for this specific structure, you're gonna get sp2 orbital, meaning this is gonna be all in plane, and we no longer observe the stereochemistry here. Oh, another thing is that when you, okay, here we had the plane sp2 here on the early, and then we move the hydrogen to fill that hole, right? Fill that carbocation. What happens is you bring it again to the new location, and you have the hydrogen, and then in perspective you want to create the wedge shape, because you just push the hydrogen, the dash hydrogen here. So that has to be pushed, or that has to pop toward us or above our page, and then now that the wedge is disappears, and then you can just imagine for now you want to have this. Okay, but we still have the methyl that's popped up. So if that was a hydride shift, let me also write that hydride shift. Now we're gonna have a methyl shift. We can move this toward that carbocation and then fill that up, and in turn we're gonna move our carbocation to the left. So when you move that, the stereochemistry is still gonna direct us to have the methyl group as wedged, as you see in the compound B here. And then this has sp3 hybridization, so to get the 109.5 degrees we have to have the dashed with the rings attached to it. And that's why you have this stereochemistry with both methyl up and the other down. So we have like cis looking wedge shape here. Okay, so I explained we undergo a hydride shift first, and then the methyl shift next, and then the stereochemistry is still retained with respect to that dashed first, and that pops up our methyl, and then this methyl is still retained after forming the sp2 carbocation, which becomes a flat here, and then when you introduce that to the carbocation, when you introduce the wedge methyl group to the carbocation, and by the sp3 hybridization, it's going to create the the dash shape for this part. And that's it.